Impact of climate change on the forest. Climate change is the challenge of our days. The changes affect every element of the world around us. It is no different in every element of the ecosystem, such as the forest that covers 1/3 of our country.
Wszystkie dane, obserwacje meteorologiczne wskazują na to, że klimat obecnie jest cieplejszy niż był jeszcze kilkadziesiąt lat temu.
All the data and meteorological observations point to the fact that the climate today is warmer than it was just a few decades ago. In fact, since the end of the so-called Little Ice Age, we have been dealing with a systematically rising trend in global temperatures. The average air temperature today is 1 degree higher than it was just a few decades ago. In addition, the frequency of extreme weather phenomena, so-called climatic anomalies such as hurricanes, periods of drought and fires, is increasing. These phenomena also have certain implications for the functioning of nature on a global scale, including forests.
Dla funkcjonowania przyrody na świecie, w tym również dla lasów.
The trees, just like black boxes, mark each year and their cross-sections as they grow. Going deeper, we can clearly see how the climate and the condition of the forest have changed over the years. In our latitudes and under the resulting climatic conditions, seasonality and seasons, trees produce wood divided into early wood and late wood.
Niby zwykły kawałek drewna. Jest to przekrój poprzeczny.
It seems like an ordinary piece of wood, a cross-section of a tree, but if you look deeper, you can see the annual increments, i.e. darker and lighter colored stripes. This is early wood and late wood. Every tree has a specific growth pattern. Early wood and late wood differ in color because they are formed at different times of the year, and differ in the size and thickness of the cells from which they are formed. First, after the start of vegetation, early wood is formed, which is light in color. Then, late wood is formed, and the process of annual ring formation ends in late summer or early autumn.
Na przekroju poprzecznym drzewa.
The cross-section of a tree shows which years were better or worse, as can be seen in the widths of the annual rings. But in order to illustrate this, so-called dendrochronological curves are created, which show us which years were good and which were bad for the life of the tree. The width of the annual rings in any particular year is determined by the amount of precipitation, its distribution over the growing season, and the temperature. No tree will ever have the same sequence of annual increments. You could say that this is a unique code for each tree, comparable to a barcode. And why is this code so distinctive? Because it depends on many factors, which in nature are not constant, and in recent years have become more and more diversified and are called climate change.
Ze zmianami klimatu jest tak.
The point about climate change is that these changes are also recorded in the cross-section in the tree through the different widths of the rings. The science that explains all of this is dendrochronology, which can be read from the rings of trees. The increment of trees contains information that cannot be seen, but can be deciphered. However, in recent years there have been phenomena and anomalies that can already be seen in the tree rings with the naked eye. These are low precipitation amounts and their uneven distribution, especially during the growing season. Can we somehow prevent the negative effects of climate change? What are we doing, and what can we do in the forest to limit them? Since a forest, like any ecosystem, is a complex network of interconnected organisms, it is important to remember that changes for one species may mean new conditions for many others as well.
Według najnowszych prognoz opartych o metody modelowania
According to the latest forecasts based on modeling methods, the image of Polish forests may change in the near future.
prawdopodobnie sosna, świerk czy brzoza.
Pine, spruce, and birch will probably disappear, while species such as beech, oak, and fir will survive.
Niewątpliwie może mieć to także poważne konsekwencje dla świata grzybów.
Undoubtedly, this may also have serious consequences for the world of fungi, and not only pathogenic fungi, which are usually closely related to a particular tree species. This will also apply to some ectomycorrhizal fungi species. Therefore, the species composition of fungi collected by mushroom pickers may probably change in the nearest future. This will especially concern species closely related to a particular species of tree. As Poland is considered a country of pine trees and the majority of mushrooms picked during the autumn mushroom picking are those found in pine stands, it is likely that in the future we will no longer have the opportunity to pick Baebolites, Ceps or Chanterelle,
Podgrzybków, prawdziwków czy też szkórek. Chociaż te
although the latter can also be found under other tree species.
Zmieniający się klimat,
A changing climate undoubtedly affects all the components of a forest,
ale grupą organizmów, która odczuwa te zmiany,
but the group of organisms that feels these changes to the greatest extent are probably insects. This is because insects are ectothermic organisms, which means that they are very strongly dependent on climate parameters, above all on temperature. Temperature regulates the occurrence, ranges, dispersal in the environment, as well as the reproduction of insects.
Warto wiedzieć, że jest to całkowicie naturalne zjawisko.
It is worth knowing that the greenhouse effect is a completely natural phenomenon. It is a very important element of the energy balance of our planet. In short, it consists in the fact that from the solar radiation, the part which reaches the Earth's surface is radiated back to the atmosphere in the form of infrared radiation. Due to the presence of greenhouse gases in the atmosphere, it is directed back to the surface and thus contributes to additional heating of the Earth's
W ten
surface.
sposób przyczynia się do dodatkowego ogrzania powierzchni Ziemi.
Scientists have calculated that the greenhouse effect increases the surface temperature of the Earth by as much as 33 degrees. That is to say, without this effect, the average surface temperature would be minus 18 degrees Celsius. But thanks to this effect, it is plus 15 degrees Celsius. Without this effect, there would be no life on Earth at all. Therefore, the greenhouse effect itself is something very positive. The problem is that human activity leads to the fact that there are more and more greenhouse gases present in the atmosphere.
Tu chodzi głównie o dwutlenek węgla.
The main issue here is carbon dioxide, the amount of which in the atmosphere is constantly increasing. Whereas at the beginning of the 19th century it was 280 ppm, today it is over 400 ppm. As the concentration of greenhouse gases in the atmosphere continues to rise, we have to expect that this will translate into more and more warming and that these climate changes will keep progressing in the direction we have been observing so far.
Ciągu będą postępować w tym kierunku, jak to już obecnie obserwujemy.
In certain altered conditions, as in the case of droughts or insect infestations, small-seeded species such as birch, aspen, alder, larch and pine are used to prepare the soil and the habitat for more demanding tree species. Invariably, very good results are obtained when foresters support nature itself, i.e. natural regeneration in forests. More than 100 years ago, Professor Władysław Schafer, drawing various lines on a map, established the boundaries for the basic forest-forming species of Poland. Recent research, however, has completely changed the perspective on the stable limits of forest tree ranges. In recent years, the condition of the basic forest-forming species has changed considerably under the influence of changes in the rainfall distribution and increased temperatures. The greatest defoliation, i.e. loss of assimilative apparatus, was observed in such species as spruce and oak, whereas fir and beech were in the best condition. The condition of tree stands is also reflected in the appearance of primary pests in forests, which eat leaves, but also in the appearance of secondary pests, of which the bark beetle is the most dangerous. On pine, it is the sharp-toothed bark beetle and the six-toothed bark beetle, and on spruce, the European spruce bark beetle and the small print beetle. Bark beetle outbreaks are an undesirable phenomenon, especially in timberland. The point is that the bark beetle kills hundreds and thousands of trees, leading to tangible losses. For this reason, foresters deal with this problem by removing infested trees wherever possible and taking them out of the forest. In this way, they reduce the size of the population of this species in an attempt to minimize losses in the forests.
Jednym ze skutków zmian klimatu, które obserwujemy, zwłaszcza nasilone w ostatnich dekadach,
One of the consequences of climate change, which we have observed particularly intensively in recent decades, is the invasion of alien species. Species of plants, invertebrates, vertebrates and microorganisms.
Tychże właśnie roślin, zwierząt i mikroorganizmów.
The problem worldwide involves around 120,000 species, namely plants, animals and microorganisms. In Europe, this number long ago exceeded 10,000 taxa. In our Polish forests, we have a considerable number of invasive plant species. Of the 3,500 vascular plants in Poland, around 1,000 are alien species. Many of them show invasive tendencies, such as this small-flowered touch-me-not. There are many of these plants in Poland. It is difficult to say what the final number is, actually, because due to globalization, just as we used to have impassable oceans and mountain ranges that would act as a natural barrier to the spread of these species, at the moment globalization of linear objects such as highways or railways has made it easier to spread diasporae, be they plant species or spores of fungi and other organisms. How these species affect the ecosystem often manifest the edifying properties, so-called edificators. That is, they take up all the space.
Mamy wiele obserwacji, które wskazują na to, że
We have many observations which show that climate change is having an impact on forest ecosystems. Particularly the scale of damage caused by various biotic and abiotic factors is constantly increasing.
dobrym przykładem są szkody w lasach powodowane przez
A good
huragany.
example is the damage to forests caused by hurricanes. I mean, for example, the hurricane in the Pisz forest in 2002. It was a major disaster, and at the time it was said to be the hurricane of the century. We assumed that something like this would not happen again at least within the next 100 years. But 15 years have passed, and in the Tuchola forest we have an event which, in terms of the scale of damage, is 3 times greater than the damage that occurred in the Pisz forest 15 years ago. Ever more changeable and violent weather conditions, especially drought, are having a negative impact on the functioning of forest ecosystems in Poland, in Europe, and throughout the world. They have a strong influence on the state of health of individual tree species, such as spruce, ash, and more recently pine, which until now has been the most stable of all species.
Znajdujemy się w drzewostanie sosnowym, który od 2015 roku...
We are now in a pine stand that has been systematically subjected to decay since 2015. In 2015, these emerging snags in this part of the tree stand were symbolic, just single pieces.
W 2019 ta dynamika była na tyle...
In 2019, this dynamic was so strong that we harvested more than 1,000 cubic meters of seasoned timber here. We consider changing climatic conditions as the main cause of the decay of tree stands, already widely described in the literature as far as pine stands are concerned. The lack of moisture and high temperatures were the factors that caused this stand to completely decay. Mixed forests, which contain large number of species, are more resistant to hurricane winds or droughts and recover more easily from disturbances in the ecosystem.
Jesteśmy akurat w miejscu, w którym
We are just at the location where these decaying pine stands have been cleared. We can see a trace of the presence of mistletoe. After consultation with Zoll, we have also carried out an analysis of the colonization of these crowns, whether pests of economic importance appeared or had an impact on it. It turned out that they did not occur in this particular stand. The main factor causing the dieback of this pine tree in this fragment, which is about 7 to 8 hectares, was a lack of water. The climatic conditions, which overlapped here since 2015, caused a large-scale dieback of pine trees. We have been very fortunate here, because the stand, the second story of which is exposed, is the beginning of a new reconstruction which will be implemented in fact just over the next year.
Bardzo dużo wypadło nam tutaj drzew, dębów, sosen.
We have had a very large number of trees lose here. Oaks and pines, we assume this is mainly due to the extreme weather conditions in 2015. Very high temperatures, droughts, all of this caused a lot of trees to fall out. We are seeing more and more such phenomena, more and more often.
Te procesy wypadania drzew nie są rekompensowane procesem.
The process of tree loss is not compensated for by the process of new trees growing up, if any. Then species which are more tolerant of drought, such as hornbeam and maple, appear, while those species which are more demanding in terms of humidity disappear. The spruce is already a classic example of the impact of climate change on our forests. Spruce is one of the species most threatened by these changes, which are currently taking place. The scale of the problem is enormous and is constantly growing, and at the moment it is difficult to expect the situation to improve in any way.
Ssaki są zwierzętami stałocieplnymi, także zmiany klimatu, które obserwujemy, nie wpływają tak szybko.
Mammals are warm-blooded animals, so the changes in climate that we are observing do not affect their population so quickly. In other words, these changes are not as spectacular as, for example, in the case of insects, amphibians or reptiles. Nevertheless, we can find many examples where we are already observing the impact of climate change on mammals. Perhaps the most obvious and well-known such species is the wild boar. If we have mild winters and little snow cover, then wild boars have easier access to food. They can nuzzle, dig into the ground, and the snow does not hinder their movements. So they are animals in good condition, and the winter death rate in wild boar is certainly much lower. This is why we are seeing an increase in numbers in this species in Europe. Hibernating species, i.e. species that go to sleep for the winter, are certainly an interesting example, such as bears and badgers, so the time of hibernation and winter sleep is shortened. Later, bears hide in their lairs or badgers in their burrows, and they wake up earlier, and they are also active during the winter, which used to be observed only sporadically or not at all. We expect quite a significant impact on bats. Here it also concerns hibernation. They can be active during the winter, or they change the places where they spend the winter. For example, they will not migrate somewhere to the south, but they will be able to spend and survive the winter somewhere in a hollow, which was impossible during harsh winter frosts. It is certainly worth mentioning those species that go white in winter. Their fur turns white. That would be the mountain hare, the ermine, and the weasel. Of course, it makes evolutionary sense that in snow these animals are not visible to their pursuers or predators. If there is no snow, such animals are easy prey for predators. On the other hand, weasels, ermine will also have problems with hunting because they will be visible to their prey. There are places in Poland where whole tree stands are dying back. Particularly vulnerable are those that have developed in depressions, valleys of larger rivers, and smaller watercourses, the so-called hydrogenic habitats. These include swamp forests, boreal spruce forests on peat, alder swamp forests, including peat swamps, and riparian forests. In most of these environments there are refugia, i.e. refuges of interesting protected plants. Unfortunately, as a result of climate change, especially the deterioration of water relations, some of them are extremely endangered and threatened with complete extinction if the changes continue at the current pace. A whole range of species can be distinguished here. These include boreal species and so-called glacial relicts, i.e. plants that witnessed the last glaciation and have survived to the present day.
Rozwój każdego torfowiska jest zależny od ilości wody.
The development of any peat bog depends on the amount of water, and in particular on the level of groundwater. The lowering of this level by a reduction in the amount of precipitation causes the expansion of shrubs and woody plants, which in the first place transpire water and in the second place penetrate the peat layer with their roots, introducing atmospheric air into the peat and accelerating the decomposition of the peat, which has been stored there for thousands of years. Riparian communities in our conditions are connected with fertile and moving flowing water, and most often occur in the vicinity of watercourses, rivers, and here we have such a watercourse in the neighborhood, which was reclaimed in the 1960s due to the scarcity of grasslands. In the areas adjacent to the forest, there are meadows where the production of green mass was increased, but it did not remain without influence on the surrounding forest. Its structure has changed, especially with regard to the undergrowth. This is related to the lack of annual flooding and the lowering of the groundwater level.
Roli torfowisk na świecie i ich funkcji, jeżeli chodzi o magazynowanie wody.
The role of peatlands in the whole world and their function in terms of storing water, carbon dioxide and other greenhouse gases could be discussed for a long time. But let me just give you a few figures, namely that the entire surface area of peatlands on Earth is about 3.5 to 4.5 million square kilometers, and they retain about 30% of all carbon stored in ecosystems on Earth, up to 650 gigatons of carbon dioxide. In addition, other greenhouse gases such as methane and nitrous oxide are also retained here, and it should be pointed out that nitrous oxide has a negative impact on the climate.
Działa negatywnie na klimat nawet 200-300-krotnie.
That is even 200 to 300 times greater than in the case of carbon dioxide.
Zmagazynowany na świecie.
The carbon dioxide stored in peatlands worldwide is actually twice that of all forest ecosystems on the planet.
Dlatego tak podniosła jest rola tych torfowisk.
That is why the role of these peatlands is so important. Of course, if they degrade, if they dry out, if the peat decays, then such peat bogs act as huge emitters of these particular greenhouse gases. In our latitudes, peatlands with undisturbed water relations have a high capacity to sequester carbon from the air, due to the fact that peatland vegetation has little decomposition potential, as it dies and thus accumulates carbon. However, as these peatland systems are very sensitive and vulnerable to disturbance, drainage or climate change, they can reverse this process, resulting in the release of carbon dioxide from the peatland surface. Peat, which usually has a fibrous structure, changes its structure as a result of drying. This structure gradually changes into a dusty form, which can be seen on the cross-section of the deposit where we are. In the layer close to the surface, we have a large admixture of mineral parts and decomposed organic substance, which releases carbon dioxide undergoing further decomposition.
Dwutlenek węgla ulegając dalszemu rozkładowi.
Ostatnie zmiany klimatyczne, zwłaszcza jeżeli chodzi o
Recent climate change, especially when it comes to higher temperatures, especially over 2 decades, because it has to be said that the World Meteorological Organization has described 2019 as the warmest year since instrumental meteorological measurements, that is, since 1880. Peat bogs are also suffering. As far as Polish conditions are concerned, around 850,000 hectares of forest land have been reclaimed.
Chodzi o torfowiska wysokie, przejściowe, a nawet i niskie. Przede wszystkim te, gdzie
As regards raised peat bogs, transitional peat bogs and even lowland peat bogs, especially those where peat mosses dominate the moss layer, their role in storing carbon dioxide is priceless, which is very important in terms of climate change, and the drainage of water from these bogs is delayed. In addition, it has a positive effect on the entire landscape in which it is located, of course, if it is not drained, if it does not decay, if there are no signs of peat recession. It is worth saying that such peat grows very slowly, about 1 millimeter a year. So 1 centimeter is about 10 years, 10 centimeters, 100 years, and 1 meter, about 1,000 years. You can do such an experiment here. I've got a little stick here. It's a bit of an open area here.
Teren trochę odkryty.
It could easily have gone in further, but it is about 1 meter, maybe 90 centimeters, and we can assume that this peat bog is 800 to 1,000 years old.
Można domniemywać, że to torfowisko ma 800 000 lat.
In fact, it was created then, and maybe it is even older. It grows very slowly, but degenerates quickly. The succession changes are very serious here.
Jeżeli chodzi o dobrze zachowane torfowiska,
As far as well-preserved peat bogs are concerned, such objects on hydrogenic soils in the state forests, we protect these objects within the framework of small mountain and lowland retention. At the moment, we have about 1 million cubic meters of water stored and retained. And this project is still in progress.
Doskonale wiadomo, że jednym z najważniejszych czynników determinujących pojawianie się owocników są opady.
It is well known that precipitation is one of the most important factors determining the appearance of fruiting bodies. So it is theoretically to be expected that prolonged periods of drought associated with climate change will adversely affect this process. However, fungi are highly adaptable organisms, and it may well be that these gloomy scenarios will not entirely come true. A perfect example of this can be seen in 2019, when, despite prolonged periods of drought during the summer, we saw an abundant emergence of mushroom-fruiting bodies, including edible mushrooms during the late autumn. This was most likely related to the intense rainfall during the autumn period of late September and October. Mammals are, of course, a fundamental part of the forest ecosystem, so there will obviously be changes here. New species will appear, or the ranges of those currently found here may shrink, so the forest will certainly change, the fauna will change. However, as far as mammals are concerned, this will be a long-term, slow process, and certainly not as spectacular as in the case of other animal species or, for instance, plants. One of the insect species which has undoubtedly benefited from the changing climate is the praying mantis. It is a very thermophilic insect. Therefore, in forests it is associated with the presence of open habitats, such as clearings, sunny forest glades, roadsides and forest edges. Until recently, the common praying mantis was a very rare species, which is why it was placed on the red list of endangered species and also placed under species protection. In the last dozen or so years, however, there has been a significant expansion of the area of occurrence of this species towards the north and to the west. Currently, this praying mantis can be found in the vicinity of Warsaw, Białystok and even Suwałki.
W świetle obserwowanych obecnie i przewidywanych dalszych zmian klimatu rodzi się naturalnie pytanie.
In the light of the climate change that is currently being observed and is predicted to continue, the question naturally arises as to what impact or potential impact these changes are having on the fungal world and the appearance of fruiting bodies. The most spectacular and easiest to perceive impact is the change in the phenology of the appearance of fungi as observed both in Europe and worldwide. Analysis of the data on the occurrence of fruiting bodies of more than 450 species in Western Europe has shown, among other things, that many species are shifting their phenology in autumn and producing fruiting bodies longer, but at the same time later. For many years, the state forests have been counteracting the negative effects of climate change, primarily by building so-called small water retention facilities to retain water in the forest. Foresters are also changing the composition of forest species so that they have the best chance of surviving in the new conditions.
Leśnicy w codziennej pracy wykorzystają bardzo wiele narzędzi geoinformacyjnych.
In their daily work, foresters use a great many geoinformation tools. One of these tools is the digital terrain model. it is a digital representation of the ground surface. As climate change is mainly associated with the problem of droughts, all activities aimed at retaining water in the forest need precise information. A digital terrain model is one of the tools that enable water management within catchment areas, also within forest areas. So, in order to plan activities related to water retention, it is necessary to have very precise information about the topography. The technology which makes it possible to reflect the exact shape of the terrain includes aerial laser scanning. It involves such technology which is placed on a plane, flies over an area, and then obtains information. As a result of the fact that we can't see the forest, we can see a network of watercourses under the canopy, which we couldn't see before because they were hidden by the crowns of trees. And this is one of the tools that we use in forests at the moment to plan activities related to improving the moisture conditions of forests. The changes are substantial and difficult to predict. But within the framework of Natura 2000 sites on the land of the state forests and within the framework of a comprehensive project for the protection of species and habitats on lands managed by the state forests and small water retention, foresters have taken actions to protect species and ecosystems. They have also actively contributed to retaining water in the environment. The idea is to create as many small objects as possible, which, by fitting into the landscape, would retain as much water as possible, hindering its flow. By autumn 2020, about 100 million cubic meters of water had been stored in state forests as part of small-scale water retention. Such areas have also been subjected to drainage and reclamation in the past, which has resulted in the encroachment of woody vegetation in these areas. The active protection measures that we carry out are aimed at stopping the outflow of water and limiting evaporation. They consist in building dams and removing trees in order to reduce transpiration. This serves to maintain the carbon sequestered in the ecosystem and reduce its release into the atmosphere. Forestry and silviculture are now facing a very big challenge to develop some kind of action, an action program which would aim to increase the resilience of forests, to increase the adaptive capacity of forests in relation to the changes that occur in the environment. We are talking here about the need to develop a certain strategy of actions, and in this context, 6 main directions of actions are particularly emphasized. Firstly, formation of tree stands with diversified species composition, formation of mixed tree stands. This activity is figuratively defined as a kind of ecological policy. The second direction of action is to increase the age of diversity of tree stands. Such tree stands are generally resistant to the impact of various harmful factors. The third direction involves taking care to preserve the high genetic diversity of individual forest tree species, which is a very important issue as a basis for preserving the high adaptive capacity of trees in relation to changes that take place in the environment. Yet another direction is breeding work, activities aimed at increasing the resistance of individual trees, individual specimens. This is a very important direction, especially at the stage of cultivation procedures. The fifth direction of action is what I would call preventive reconstruction of tree stands, which are most threatened by changes in the environment. We already have a large number of such tree stands, and the list of these stands is constantly growing. Finally, the final course of action is to prevent excessive growth in the abundance of tree stands. Gradually and wisely, foresters are adapting forest management activities to the coming changes. The basic one is dispersing breeding risks. This is a difficult task, as one must be a good observer and not be overtaken by upcoming changes, but at the same time the wildness and diversity of our forests must be preserved. This presupposes the creation of complex and diverse forest ecosystems through actions at the stage of establishing new crops. Mixed forests, which contain a large number of species, are more resilient to hurricane winds or droughts and recover more easily from disturbances in the ecosystem. It is also good forestry practice to introduce so-called biosynotic species, i.e. fruit-bearing trees and shrubs that support the appearance of birds and insects. Appropriately selected tree species can complement each other, e.g. in terms of light or nutritional needs. It is also important to support species that are valuable to our forests, but are beginning to decline as growing conditions change. These include Scots elm and common elm, European ash, and the black poplar. The growth of species which used to be important in forests but for various reasons have started to decline, such as linden, sycamore, wild cherry and yew, is also promoted. It is also important to select from the basic forest-forming species those trees that have best adapted to changing climatic conditions. In the seeds of such trees, the characteristics of the parent are reproduced, so we can assume with some probability that the resulting young generation will also be more resistant to the changing climate. In those fragments where we have the second story, we are not afraid. We know that in combination with good forest management we can somehow manage and restore this stand. In the fragments where this process was destructive on the whole area, we see a chance in the new generation. The moisture conditions before 2015 and after 2015 in our area are significantly different. The pine trees which had enough moisture and freshness in the soil before 2015 were able to develop root systems which were sufficient for them to survive. After 2015, with the lowered level of groundwater, high temperatures, mistletoe appearing on these weakened stands, i.e. increased transpiration, this led to the fact that the pine tree practically disintegrated completely within one growing season. We think that in this new generation that we see here on the horizon, this pine, with this shortage of moisture, will develop an extensive enough taproot system to restore the stand as it was before 2015. In the context of these various threats and challenges that forests and forest management face, the concept of semi-natural silviculture is much talked about. I think that this is indeed a good direction in which we should go.
Ja myślę, że to jest rzeczywiście dobry kierunek, w którym powinniśmy iść.
Semi-natural silviculture aims at shaping tree stands with a diversified structure with the use of such natural processes to the maximum extent. I think that the possibilities in this area in Polish forests are very extensive, but I would also like to emphasize that semi-natural silviculture is not just a simple imitation of natural processes. They do not always go in the direction we would like.
Proste, zwykłe naśladowanie naturalnych procesów. One nie zawsze idą w tą stronę, w tym kierunku, w jakim byśmy sobie życzyli.
Very often we have to act against the tide, against these natural processes, in order to maintain the multifunctional character of forests. Tree stands to shape diverse and resistant tree stands. Very often human action is needed here, active human action, and I think that this is the direction we should follow.
Człowieka, aktywne działania ze strony człowieka i myślę, że to jest ten kierunek, którym powinniśmy iść.
Kostrzyca Forest Gene Bank can be called a forest time capsule or a Noah's Ark, storing endangered and rare seeds of tree species, shrubs and other valuable forest plants, whose populations in the natural environment are on the verge of extinction. Noteworthy is the project of banking and barcoding of individual plant species from the Białowieża forest. including, among others, glacial relicts, boreal species, or species extremely threatened with extinction, also as a result of climate change. Another task of the Forest Gene Bank in Kostrzyca is to assess the suitability of seeds for sowing, which is a very important stage in the further breeding of seedlings. Evaluated batches of seeds, appropriately prepared for sowing, will go to forest nurseries and in the future will create new forests. The Forest Gene Bank also has a mycorrhizal laboratory, where a preparation is produced that produces mycorrhizal compounds when inoculated into the roots of seedlings. Seedlings inoculated with mycelium are more resistant to various stress factors, such as drought, increased temperature, altered soil pH, or lack of natural fungal compounds in the soil. Mycorrhiza is a symbiosis that gives the seedling increased root area, but also insurance as the fungi produce antibiotics, micronutrients, and certain hormones that accelerate growth. On the other hand, the seedling gives the necessary mineral salts to the mycelium.
W dzisiejszych trudnych czasach, dużych wyzwań przed lasami.
In these difficult times of great challenges for forests and forestry, silviculture must be better than nature. It must be better in the sense that we have to anticipate certain processes, certain phenomena, and respond in good time, preparing our forests for the unforeseen environmental conditions we face today. People associated with forests show an understanding of the processes around us. The long-term effects of climate change and their intensity are difficult to predict. Foresters and scientists, however, are trying to counteract these processes. They rely on knowledge, experience, and analysis of climatic and natural data. They also use various models, including modern neural network methods. Many programs have been developed to counteract climate change and to mitigate its effects, as well as many schemes for dealing with various types of disasters. Man is responsible for many of the adverse environmental changes we see today. It is therefore our generation that has a special duty and responsibility to preserve healthy, diverse, and vibrant forests for future generations.